Hello, everyone. How are you doing today? It's very nice to see all of you joining us live today. And welcome to the webinar. It's about physical AI, future outlook, ecosystem, and industry use case. So I hope you all seeing my screen right now. And just let's have a bit warm up. Could you share in the chat where you're joining from today? Uh, uh, mm, oh, I love to hear where you're joining from today. I know our speaker is from the US and Australia. We personally joined from Hanoi, Vietnam. Uh, so yeah, just sharing a comment. Do a bit of warm up, staying friendly. Yeah, I see some people from Vietnam as well. Calling on. Mhm. Hi. Yeah, I think just some warm up, waiting for people to join. So, hi, Joshua. Hi from Japan. Very nice. Oh, from Taiwan. Hi. Okay, so I think we should start. We have quite a lot of people right now. So once again, I'm Beckley, the physical AI expert at LTS GDS, and I'll be your host today. So we are very excited to guide you through the real world story, insight, and then also the data about the physical AI. And just a little bit, physical AI is the technology, the concept that is moving the AI out of the screen and into the real world through robots, um, every shape of robots. There are a lot of robots. Autonomous machine intelligence system that can send, understand, and also interact with a physical environment. So that's about physical AI. So, whether you're a CTO, engineer, consultant, or, just like people love tech, we hope you all find this webinar thought-provoking and interesting. We all hope you, leave this webinar with some new knowledge. Yeah. All right. So to bring this topic to life, I'm joined by two experts that have spent many years working in the industry as well as global companies. So please welcome. We have Mr. An joining us from Silicon Valley. He is a senior data infrastructure engineer at Hippo Harvest. An brings over 15 years in data engineering and software development, with hands-on experience spanning many domains. His expertise is on AI infrastructure, where the scalable data architecture and decision-making system that make the autonomous system actually work, like real. So I will give us the Silicon Valley lens on the physical AI market and then the trends that is shaping it. As well, we have Mitchell Hua joining from Australia. He is a robotic engineer at Neuralink and a PhD candidate at University of Technology, Sydney. Hua developed autonomous robotic solution for critical infrastructure with experience across industrial AI, robotic, mapping, intelligent inspection system. He sits right at the edge of academic research and in commercial physical AI deployment. And finally, I will be your host and sharing perspective from LTS Group and LTS GDS on the emerging role of Vietnam in a global physical AI system. So, before we start, I'd like to invite each of our speakers to briefly introduce yourself and share one thing you're most excited to discuss today. An, would you like to start?
Okay. So okay. Thank you. Thank Mike for introducing me. So again, my name is An. I'm a data infrastructure engineer at Hippo Harvest. It's a farming company. So using robotics and AI. So yeah, I think Mike introduced me already. So I should say I have been working in like more than a decade. in software and data and AI engineering in different domain. Today I'm working in agriculture, but previously I work in manufacturing, maritime, and other kind of industrial AI system. So I'm here today.
Okay, thank you so much, Alan. I'm sure you're gonna have a lot to talk about later. Right. How about you, Hua? Do you mind sharing a bit about yourself and what you're most excited to talk about today?
Yep, thank you, Bud, and thank you, Mr. An. My name is Hua. I'm currently a robotic engineer at Hurling, which is a pipe inspection company where we develop autonomous solution for inspecting pipe networks and help companies and government to manage their pipe infrastructure. And I'm also a PhD candidate at the University of Technology, Sydney, in robotics. So I'm very excited to be here today and hopefully to be able to share some of the insights and some of my opinion about the current landscape of physical AI and robotics in general.
Thank you so much, Hua. I know that our audience love to hear more about you, especially when you're doing grid pipe, very critical infrastructure. All right. So, now we met two brilliant speakers. Let's quickly work through what we coming up today. What's our agenda look like? So in the next 60 minutes, we're gonna go through 4 focus sessions. The first one, we're gonna examine the global physical AI landscape and perspective from the Silicon Valley and Australia. After that, for the second session, we'll look at how industry are applying physical AI today with use case across various domains. For the third session, then we have a five-chat slide. Our speaker will take turn discuss what's next for the physical AI wave, including key challenge, strategic consideration for organization preparing for future adoption of physical AI. And finally, for the final session, we're gonna open the floor for a live QA session and also expert discussion. Anyone with a question, we love to hear that. Our speaker love to answer that question for you. Yeah. So don't worry, we'll keep it sharp and relevant for all of you. Right. So first session, global physical AI market. Where are we today? So now let's kick things off with a big first question. How are the global physical AI market? We can see the true largest, we know that the true largest market in the global physical AI landscape today are the US and then China, each with a strong ecosystem of leading innovators. In the US, key players include NVIDIA, Tesla, Figure AI, Google DeepMind, researching powerhouse. Meanwhile, in China, they're rapidly advancing with companies such as Huawei, Baidu, Unitree, and Alibaba. So, of course, beyond these two markets, Europe is also home to major physical AI and industrial automation leaders such as ABB, Kuka, Siemens, Anybotics, and Universal Robot. In Japan, companies such as Toyota, Yasakawa, Fanuc continue to play a significant role in our robotic and automation. Meanwhile, in Australia, organizations such as Rio Tinto, Amazon are exploring physical AI application in mining, infrastructure, and autonomous system, which they are very famous for, especially mining. So we're just taking a quick tour of the global physical AI landscape now to gain deeper insight into two critical markets like the US and Australia. Let's hear from the guest speaker today. Recently, at NVIDIA GTC Taipei 2026, NVIDIA announced Cosmo 3, a frontier, army model. It can be like a war model. It can be a virtual language reasoning model. It can be a VOA model with action. So this is a push for physical AI from NVIDIA. So we want to ask you on, from your perspective, what does this mean to embody AI in general? And what are the other emerging trends and notable developments you're seeing in the physical AI ecosystem, especially in Silicon Valley? Yeah.
Okay. Yeah. Okay. Yeah. Let me talk a little bit about my perspective first. So at the data infrastructure engineer at farming company working in, using robotic and AI. My role sits at the intersection of data, robotic, machine learning, and decision making system. So what I have learned over time is the most difficult problem is not about the AI, the intelligence, but like how to it operate in the real world. So let's go through on the wave. I mean, the main three waves we have been seeing today. It's generative AI, agentic AI, and physical AI. When I put it, the pipeline look like linear, but actually it doesn't happen linearly. It's happen in parallel. Like, with generative AI, you can create and interpret the information. With agentic AI, we can plan and coordinate to make a workflow to achieve a goal. Physical AI go beyond this to connect the decision to the real world operation. This happen together, and overall physical AI is not limited to robot. It's not just robot, but like the whole loop, the whole system influence the physical entity. So why does it matter? It brings us the engineering bottleneck is shifting from AI can act to AI can act reliably in a reliable way. Let's go to the next slide. So there are many ways to break down the step of doing physical AI. But like I put this like framework is kind of like easy to understand the whole flow. So first, like it's kind of very straightforward. First, before we know we understand everything, we observe first, like, okay, what is out there? Then we try to understand, okay, what does it mean? Then the next question is what to do with it? What matter? What are the things we want to fix? What is the problem we want to solve? That's the design. And then once we have all those things on the table, how to bring that into the real world is act, and it does not stop at like the action, but okay, when the real like machine were acting in the real world, we want to measure it because like we want to improve it. What we can learn from this, and it go back to observe everything and understand everything and design the next cycle. So it's the whole loop. So physical AI like it include autonomous machine, industrial system. Of course, like their AI seated in every layer of the whole operation. And yeah, not every system needs the fully autonomous system. This depend on what type the problem you want to solve in which world.
Thank you so much. I also agree with your opinion that like now the technology is just like much better, and so we can going from like the AI can do something to the AI need to do it reliably, right? So that's the trend of the physical AI new wave, and I think that's a very great insight. Yeah. So great. How about Australia, Hua? We want to ask you where is physical AI market is heading in Australia.
Oh, okay. Thank you. So yeah, Australia is a pretty interesting market in terms of physical AI, from what I can say. So if we look at the US right now, we can say with be among the two major players, the US and China, right? The majority of frontier research and frontier development that we've seen in the last few years were all from the US. In China, we can say it is more of a mass deployment market, where all of the companies are focusing on making the cheapest and most efficient humanoid robots or physical AI as they can possibly do. Australia is a little bit different. We're more of a application-oriented market, so focusing on deploying research into the real world to solve a very particular problem. So it's not trying to create new knowledge or doing any frontier development. It's more about applying what's already available and then adjust it to meet the requirement of the applications here in Australia with a heavy focus in mining, etc. Yeah, that's how it's currently look like in Australia, which is a bit different from the other markets, from what I know.
Yeah. Thank you so much. Yeah, I think it's a good approach. Like moving directly to the application layer. I'm sure there's a lot of like very pinpoint problem that need to be solved, and Australia is like directly tackling that. While on the other hand, like China and the US is kind of trying to pursue a generalist robot, as you can say, right? Yeah. Yeah. So, thank you for sharing, Hua. Then we talk about when we talk about physical AI. Most of attention today is focused on the large market, but I want to share that Vietnam is also showing some very promising signs. We know Vingroup, which is leading the way in humanoid robotic and autonomous driving investment in Vietnam. There's also a number of Vietnamese companies are making real moves across the ecosystem. We have real-time robotic or RTR supplying drone for defense, public safety, manufacturing. We have Viettel provide UAV system for military. We have Avi drone, MiSmart, Devi drones built for agriculture sector. We also have Fenicar X developing autonomous mobile robot using the warehouse AMR. And FPT provide technology service to several of the world's self-driving car manufacturers. And also, we also want to introduce LTS GDS as a part of this picture too. We provide multimodal data solution for physical AI and robotic company. As you can see here on the screen, there's some data sample collection process for physical AI. And has been an amazing journey for us. So we also observing some growing support at the national level for Vietnam, with the Vietnam Ministry of Science and Technology establishing a national AI development fund for 2026 and 27 period under the implementation plan for the country news AI law. The government will also build a national AI database, which will be hosted at the National Data Center to strengthen AI infrastructure and data accessibility. Thailand is another area where Vietnam has a strong foundation. Yeah, yeah. Oh, yeah. So, moving to the next session 2, how industry are applying physical AI today. We'll now explore where the physical AI market stands today and the key trend shaping its development across different regions. Naturally, the next question gonna be, what does physical AI look like in practice? And to help answer that, let's move into our second uh, session here, and will walk us through the range of use case across industry, including agriculture, physical AI, manufacturing, biotech, maritime sector. So we'd love to hear that from you, On. Over to you.
Okay. I think let's spend more time on the agriculture first, because I'm working in agriculture today. Previously, I work in manufacturing, but maritime. If we have time, we can talk more. But let me talk about agriculture first. Because for me, it's kind of most interesting physical AI problem, because it can involve biology. It's not just machine. I like to say biology is more generative than the thing we call generative AI today. You know what I mean? Generative AI generates text, image, video, code, a lot of things. But biology generates life. Those are living things. They are alive. So it's something like when It means when you develop your AI model, when you type prompt, it's not just okay. The outcome of that, not just on the software side, not just on the machine side. Of course, it's happened on software, then it's happened in the machine side, but like it's also affect the living thing. And of course, like every plant, just like human, like every child have a different way of growing. Same to plant. Even on the supermarket, you may see, okay, all the vegetables look similar, all the apple looks similar, but like they are totally different. Even given the same condition, same temperature, same humidity, but every plant grow in a different way. And your challenge is to how to maintain, how to like keep it like consistently at the system. And of course, like it's not just about robotics. As I said in the previous slide, like physical AI, not just about robots. It's the whole thing, like from the beginning to end, from observing the plane, like then what to do with what kind of the intervention we want to do. Like if we don't do anything, the plane still grow. But like what are the things we want to do to make the plane grow in a different way, and how this affect the environment, because even the human had been growing plant in many thousands of years, but the way human is doing the agriculture today is very much different than 50 years ago, 100 years ago, or 1,000 years ago. Like, yeah, we do in different way, and of course the plant grow different way. So that's the main thing for agriculture. Actually, another funny story, when I introduce, like when I go to like outside, when I introduce myself, or even when my company introduce ourselves, we don't talk ourselves at the robotics company. Like for example, if someone asks what is your product, because our product is vegetable. That's the key thing. Like we are a farming company, we use AI, we use robotics. We don't, but like AI or robotics is not the goal. It's a mean to achieve the goal. So we try to like we leverage AI and robotics to maximize the production of green. Because when we mention that, it means okay, how we compete with other. It means okay, if our green, our vegetable is good. Good. I can, yeah, there are a lot of story about this, but I can share about one of the real failure in the physical world in agriculture. For example, like you know, it when in the digital world, if something like wrong, it's just like it's happened on the software side. But like in the physical world, if something goes wrong, it's like you cannot just rerun the pipeline. You cannot just restart the system. No, you have to go out to fix the consequence first. So for example, we have this case that when a watering model starts to produce some kind of weird behavior, and okay, we noticed that on the software system. But then after a lot of like troubleshooting iteration, we found out okay, actually it's went wrong from a robot arm lifting behavior. Like it's just like a punishment. Like, but like before that, when you look at the dashboard, everything is green. Like okay, everything looks good. Data is available. Model still reduced in prediction. Everything looked good, but like okay, but something look weird from the user side. Okay, now we go. It's from the robot side, and when we know that okay, it's not just fix the robot arm. It's not just restarting the system, because like the consequence already happened. When the model water the plant incorrectly, it make the plant like almost dead. Okay, we have to go out to dispose of all of the plant. They fix the real consequence first, and then go back to fix bug on the software side, on the system side, and then we can move on. It's not like an easy thing to do like in the quick way. So let's move on.
Yeah, I think that's an amazing insight. Thank you for sharing. And I think it's also like focus on the message you delivered earlier. Like we need robot that is physical AI, right? Is AI that it can do in the real world reliably. Because as you share here, it has a delayed causality, right? Because it doesn't you don't see the consequence immediately. Like and sometimes like your vegetable, it can take like a month to grow and to harvest it. But then if the model failed, you can lose like a month worth of effort, and that's very devastating, right? And usually we have like constant feedback loop, right? But we don't have it here. So
That's
uh,
true. Like for example, I can say more like for example, like if somehow that your model is wrong, you realize your model is wrong, you cannot just
mhm,
return on the next day. But like
mhm,
you will have to wait for the whole cycle happen again. Like okay, wait for the plan needs like 30 days. A plan needs 45 days to roll.
mhm,
You
mhm.
cannot deploy new model and have the new plan tomorrow. It doesn't happen that way. You still have to wait the next cycle 30 days, 45 days. At least we choose the plan that roll quickly. But like, what happens if we choose the plan roll in years? Okay, it's another challenge. So
Yeah, yeah, exactly, right. Thank you so much again. Right. So moving on, we want to hear more about the physical AI application in Australia. So over to you, Art.
Yep. Thank you, Bud. Thank you, Mr. An, for sharing. So in terms of Australia, as I mentioned before, it is an application oriented market, right? But the theme in general can be summarized into robots, field robotics, what we call field robotics. So robots that are outside in the field doing uh, what we call dirty and dangerous jobs in replacement for human. And since Australia is one of the largest mine sites in the world, have a lot of mines here, then it is natural for people to try to put robots into mine site. And it is actually a very popular application in Australia since mine sites are inherently dangerous. There's a lot of things, unexpected things that can happen inside a mine site. So it is important that we send an autonomous agent inside to inspect the surrounding and make sure that it is safe before we deploy human. And this autonomous agent can also be either be controlled by a human operator from outside of the mine site, or being fully autonomous, being like you're putting an AI model onto that autonomous agent and let it uh, comes in and sort of explore and map the entire network, like tunnel network of a mine site, and then returns out with full informations that human operator needs to be able to come in safely. And then we can also place what's it called, explosive, to remove debris before putting human in. Another application that when I was at UTS, we did for one of the mining company in Perth, which is in Western Australia, was to create a robot that can hang on a cliff and place explosive to remove some of the hanging rocks. Usually the job are done by human, but because they have human casualties recently, they kind of want to move away from using human for that kind of dangerous job, and then that's when physical AI or robots come into the play. Yeah, that's in mining. Another well uh, field that's been seeing robots is in critical infrastructure, or specifically the pipe infrastructure that my company Purling is doing right now. Um, so the idea is pipe is a very critical infrastructure for making sure that we live a healthy and normal life, right? But it is also very difficult to maintain, and since its pipes are long, and then whenever there's a problem, then people usually have to dig up like a large section. You have to dig up the road, or maybe at somebody else's backyard, and you have to dig up the entire backyard, for example, just to find and isolate the section that has the issue so that people can service that particular section. So one of the idea is to deploy a small robot, or small agents that essentially you can think of it as living inside a pipe, just moving back and forth continuously, collecting data through the form of video stream or images, and then send those data back to the control operator. And then the control operator can determine if a particular pipe section needs to be serviced. And then they can just quickly send people there and isolate that particular section instead of having to, well, dig up the entire network just to be able to service a small section of pipes. Yeah, and I think the core challenge here is the space is constrained. So usually it's very difficult to put like a traditional robotic platform or any kind of horror in there. So like you have to design the platform to suit a specific pipe diameter, for example. And usually no one solution fits all. So it has to be something that meets the requirement of the network that you are servicing, essentially. And one more, this is actually coming from a recent startup from one of the universities in, I think it's in Brisbane, Australia, which is they developed a 3D printed humanoid robot for what, and they also call this something like companion AI, something like that. And the role of it is to be a friend, a companion with elderly people in Australia. It's more for the aged care sector, where we're also experiencing a lot of labor shortage recently. So it is an interesting application, and I think it's also a very useful application of physical AI in Australia right now. Also, the company, the aged care company, is called Andromeda, if anybody is interested in having a look.
Yeah. Thank you so much, Juan. Yeah, I think these are all amazing application, sharing about his like agriculture, vegetable potentially feeding millions of people. And here you have mining, pipelining, like water, sewage, oil, gas, a lot of things move through pipe.
Yep.
And then aged care, all very like central, like centric around human, right? It's all bring real value. Yeah. I think that is amazing application of physical AI. Yeah. Right. So again, thank you for sharing. And yeah. Oh. Right. So move to the next slide. Yeah. Yeah. What's next for the physical AI wave? Right. This is a five chat section. So I would like to dive deeper into what's next for the physical AI wave. From what we are discussing so far, what are the biggest challenge shaping the future of physical AI, in your opinion?
Yeah, the biggest challenge. Let's go. Yeah, as I said in the previous slide, the biggest challenge is because there are many layers, and each layer have a different problem, and we have to solve all the problem, like from the beginning to the end. Like there are no shortcut about this. Like for some layer, it take time, but like you still have to solve. Take time to solve. You still have to wait for the result to do the next thing. It's not like a quick win. Like okay, we can do like tomorrow. Like we can have a result tomorrow. Okay, we do tomorrow, but like keep doing until the final result. And that kind of interesting because like for example, like I said, like even the human role land are doing agriculture for many thousands of years, and we are still doing today. And there are many things we have to do to know what is the right way to do, like of doing that. It's not something in textbook, like the knowledge about agriculture in the 1,000 years. Okay, it's still helpful, but like it doesn't guarantee you do the right thing today, because the way of doing things today is just different. And it's not something you can ask ChatGPT or any kind of AI tool to have the answer immediately, because like all of the AI tool is trained based on the knowledge on the internet. But like to solve this kind of problem, it's not from the internet yet. Of course, you can ask, you can look up the internet, you can ask AI to, okay, how to make a computer vision model, how to make some kind of model, how to make a data pipeline, how to make some like in a very way, but like how to solve the exact problem. Is it like how to measure, like, okay, what is the right recipe for each kind of, or this kind of plant in this condition, like this temperature, this humidity in this soil. Even the same land, if I grow in California, the North California is different than South California, is different in Washington, different in different states, of course, in different in Vietnam. So there's something we cannot transfer from this place to other place. Of course, we can transfer the knowledge of the technical, like how to build the system, but like the domain expertise is something we cannot transfer like immediately. It takes some time to transfer. So that's why it's hard in this go on. And that's about the domain expertise, about the, for example, the physical action, the machine, like how the machine, the hardware work, like behave in the real world. Because it's still early, everything is still early, so you don't have the whole, have all the collection of like how it's happened in the real world. You cannot ask ChatGPT, hey, how this happened? No, you have to wait and see how this happened in the real world. That is about the machine itself. And the biology bring more challenging. How the plant react with your models. You have to wait because the plant in the history like grow in different way, but now it's grow in different way. And every plant needs a different like recipe of nutrition. Like, yeah, that have all the thing about agriculture. That because it's involved the living system. Maritime, yeah, rapidly I work in maritime. It's very similar. The fish in the ocean, they behave differently in different regions, and it's come to like a very common problem in like physical AI, like distribution shift. Like for example, in traditional AI, when you change the distribution, you have to change everything again. But like today, like for example, the same maritime problem, if you move to a different region, it happens differently. And how to make sure your system adapt the new region, the new environment, new everything, and also the connection problem. For example, I personally, I did not appreciate this challenge before I moved to the US. But when I was living in Vietnam, I never had to deal with the connection problem because like internet is everywhere in Vietnam. But like in the US, it's bigger. It's a kind of like a continent, like the so there are a lot of remote area with there's even no phone signal, not about internet. But like we have robot machine deployed to remote site. For the robot working in mining, for mining, or like they don't have internet. More like all the robot work under sea. The robot work in the universe, like in the moon, in the Mars. There's like no internet. There's no something called cloud computing in the ocean or in the universe. So how to make your system work? How to make your AI system work reliably, even they lose all the connection. Well, like in without cloud, how can you code OpenAI? There's no OpenAI. So you have to make sure your AI work in every environment. That's the main challenge. Like, why different? Yeah, actually, like in the digital system, like, okay, when you do something wrong, you just need to redo it. When you prompt something, make a wrong prompt, a bad prompt, you cannot just reprompt it, redo it. But like physical, you have to, okay, something is lost already. You cannot reproduce the moment you have lost. You cannot, like, if you, for the, you cannot reproduce the sunlight if you did not capture it. Something you did not think you have to put into the system. Anything, the sunlight on, sometimes the storm visit your place. Personally, I have 2 storms in my career. When I work in maritime days, when a storm visit and it just like clear all the model assumption. And it's same with agriculture. Like we can lose the power, the connection, and but like the robot still working. Like of course, like during storm, human don't work. But like unless the robot die, but like if they still alive with some even with low battery, they are still working. And even they can produce something. And how we manage that? How can we do it better? Because they still working. They are not like that's the beautiful thing of robot. They working 24/7 in many different conditions. And how to make sure those things still working in reliable way. That
Yeah.
that's very different from the digital world.
I think that's very interesting, because like in some cases you mentioned, like in remote area in the US, sometimes there's no phone signal, there's no Wi-Fi, there's no 5G you can use, probably some GPS, but that's all, right? And human can probably still perform in that, but some robot can't, right? But then on the other hand, like in the storm, like in the remote warehouse where you have like backup generator, and your farming system probably still working, right? Because it doesn't rely on human to be there 24/7. So I think like physical AI is a move that it has like both advantage and disadvantage, right? But a lot of advantage. Yeah. All right. So thank you so much. That's a great reality check on what's really behind the scene. So Hua, let me ask you the same question, but from the academic perspective. Bridging research and real-world deployment in critical infrastructure, what are the biggest challenge you see shaping the future of physical AI? Are they similar to the one I mentioned, or you see different set of difficulty in your field?
Uh, yep. Thank you, Bud, for the question. Okay. I would say the challenges in general are quite similar. I think the hardest one is probably the unpredictability of the world, the real world. So if you've seen all of the recent advancement in what people are calling world model right now, technically the terms are called by the AI companies. So world model essentially we're trying to build a model where the robot can reason about the physical capability of the surrounding objects simply by using vision and actions. So hence the term, you can say it links to models like VOA, visual language action models, right? So it's similar to how it's like you can treat the robot like a baby, like a newborn baby, right? So when a baby comes to this world, the baby doesn't have any physics understanding or math understanding or anything like that. The baby doesn't know anything, but the baby can still interact with objects and perhaps expect the objects or the surrounding world to respond in a particular way. So that is the physical intuition that the baby developed purely from looking at the surrounding world and interacting with the surrounding world. And there is no physics lessons or anything like that's being used to train the baby. The baby understand that simply through interactions, and that is something we're trying to put into robots or physical AI. You can say that. But the issue with that is we're pretty much limited by the data that we can put into the robot. If you've seen all of the fancy demos of robot being able to do house chores, clean your room, wash the dishes, cooking, like a whole bunch of fancy things, or even like using tools. But like in 2018, 2019, that I remember, there used to be a competition where we had to develop robotic solutions, where you pick up a keys and insert the key into the keyhole. It is a very natural thing for human, but very difficult for robot. At that time, it's like what 7 years ago, 7 or 8 years ago, to be able to do something like that. And now we have models that's being able to do that kind of thing. But again, like all of that, demonstrations and models trained for robot are all for, I would say, for general real life thing that you usually see around. So say like very common thing like doing housework. So anything that's connected to the human life in a very common way. So things that you can collect data quickly and easily. But say for agriculture, like Anne's example, or for my my case in critical infrastructure, the data inside all of those environments are not readily available. So you can't really do anything without the data. So it's the problem of actually having the data to understand whether the thing that we're trying to model match the real world. And it is usually the hardest thing to do right now when it comes to physical AI. Yeah, and I think that's one of the things that research is trying to tackle as well. So like being able to generalize the training enough so that you can train for one scenario, but then the robot can handle other kinds of scenario. But then again, there's a limit to how much it can do without the actual data of a particular scenario. Yeah, I think that's
and thank you for sharing about that problem, the data problem, right? And I think that's also showing up with like the previous AI generation, like LLM and machine learning, right? It's only executed as the data you training it on, right? So having and then especially physical AI, getting the data is especially more difficult, right?
yes.
Thank you so much. Right. So, we build a clear picture of a key challenge facing physical AI adoption, and let's shift our focus to the most awaited part, implementation. So, again, Hua, based on your experience working with autonomous robotic platform, what steps should autonomous system builder, or in other words, like autonomous device and firmware provider, need to do to successfully adopt physical AI?
Yeah, okay. So I think it's successfully adopting physical AI. I think you should always start with the problem that you're trying to solve. So everything, like from my personal perspective, I would consider AI or robots in general are tools, and there are tools developed to solve particular problems that other kinds of tools previously are unable to solve that particular problem efficiently, right? So it's always start with identifying the problem to the details, like the nitty-gritty details that you want to solve. And then we prototype a solution that can either be through high fidelity simulators, like Isaac Sim from NVIDIA, or any kind of simulator, or even sit down and use the good old pen and paper, do some math, trying to understand a solution, like come up with a solution to solve the particular problem, and deploy and collect initial data. And then we validate the data against the initial requirements that we set in step one. And it's a rinse and repeat process. So I think it's very important that because we're dealing with problem in the real world, it will always be the case that the first prototype will never be the final solution. So it's very important to be very open-minded to failures, and embrace failure as part of the journey to adapt and make good use of the AI tools that we have to make the solutions to solve particular problem. So yeah, that's some of the insights I have.
Yeah, thank you so much. Yeah, I think, and then I think it's the process like rinse and repeat apply to a lot of like other problem, right? And then especially AI, they need just to like do it, sees what's wrong, update it, get new data, and again, right? Yeah. So thank you so much for sharing. Those are very like actionable recommendations. Right? Yeah. So how about you, On? Based on your hands-on experience, what additional advice would you give in markets across industry, such as manufacturing, logistics, looking to adopt physical AI? Yeah, what are your advice? Yeah.
Okay, actually, it's very similar to what Khoa just shared. Yeah, first you need to find the right problem. What is the problem you want to solve? Like otherwise you solve the wrong problem. Like this kind of I can use my company at the sorry. Wait, hello.
Sorry about that.
Yeah. Further, I can use my company as sample. Like if you ask me what is your product, what is my product? It's the green. First to the end user, it's the green, it's the vegetable. But like on the system side, the product is the platform to reduce this. It's not like about AI. So first on, choose the right problem first, and then do it. I mean, find the right problem and then find the solution. The solution is not something you can find at the first time you look at it. It's not straightforward. It's not something on the internet. It's not something you can ask AI to do. You have to do it over time. You can do it. Then you can, after spending enough time and effort, you know how to do this. Then you can, okay, now first you have to do it, like know how to do it manually. Then you can push in, make it automatic and autonomous way. Then you expand the use case from the evidence you had, like after a lot of experience. For in my case, we cannot like make like multi-farm at the beginning. We have to do one farm correctly first, like everything is correct, because otherwise, if we still doing something like randomly something wrong, and you scale the problem. But like if you do everything properly, then you can scale that system to another farm. Of course, with the new farm, you have to learn something new. Of course, like every site, every deployment is different. But like you will not go to the like scaling way a new site until you have already figured out what is the right solution to solve the problem you choose. That our approach is happening here. Go to so today AI has already learned to generate the answer, the plausible answer. But like the next challenge in physical AI is to generate the reliable outcome in the real world. Now we talk about AI, artificial intelligence, the intelligence, yes, attention, but like it's not everything. The key thing is the reliability. With the reliability gives you the permission to operate. Otherwise, you can break something in the real world. That's the main point of physical AI. Okay, what's next? Okay, so I think many people have already asked me this question, so I can, because everyone can have different answer. I just said my personal like opinion on like what kind of like thing that Vietnam, I mean, not just Vietnam, but like in Southeast Asia or some country like Thailand, Malaysia, Indonesia, like what this country can do. Because like different countries have different trend. And from my opinion, if I were in Vietnam, I would try not to like pursue like, for example, frontier model. That's the thing of Silicon Valley. Like Silicon Valley keep introduce new thing like new physical system, like new sensor, new skin. For example, I used to make a company in the US. They making like skin for the robot. You know, human change skin every day, every moment. But the robot doesn't have skin yet. Not yet today. Maybe like many years later. So without skin, how? I mean, the robot without skin, you cannot change, deploy your model like quickly. Human skin change every day, but like the model on the robot, like maybe after a while, not every day. You cannot replace it immediately. And I know some robotic company in the US, they are developing that kind of capabilities of the human skin. They develop new sensing system that can change and adapt over time. And this takes years, many years to do it. They are still working on this now. That's the kind of Silicon Valley is doing. So from the Vietnam perspective, I would not recommend Vietnam to do it that way. It's painful because it's you need a lot of money to do it, a lot of and patience. And for example, I used to say like, for example, when you see the robot, like just do some random thing like put the toy, play with the toy. They actually today they do it like even more slowly than a baby can do, a human baby can do today. Maybe after like 10 years it's better, but today, like humanoid robots still not the level of a human baby can do. That's the true thing. So I would not recommend Vietnam to that one. I mean, if you are a talent, you can, if you have lucky, you can find a lab that can fund you. Like the lab, they have a lot of money. Okay, you can do it. But like in overall, like I would recommend to like do something like to solve some kind of business problem, like make sure like to get some like find the problem you can solve, you can do better with AI, with robotics, and profitable. You can get revenue. So, and to do that, when doing that, you can earn a lot of things that other can not easy to replace you. For example, when you build a domain space on some problem on agriculture, as I said earlier, even with given the same agriculture problem, the way the grow land in the US grow in the US different from how it's grow in Vietnam. And when you develop, you have a unique way of solving a similar problem. For example, one of my friends in Thailand used to ask me, hey, and I want to do some kind of fruit grading system. Like, and I got what kind of fruit that he asked about durian. Oh, durian is not something the US care. So I was like, in the US, we care about like apple, strawberry, but not durian. But it's different because durian come with the smell. Current AI today, okay, we have like computer vision system with the like imaging, with the video, but like we don't care about the smell. But like if you want to do it in Thailand, in Southeast Asia country, something like this, you have to develop. Of course, you don't have to develop everything from scratch. You have like a lot of hardware sensor from China. You can buy it from China. For the AI model, like the most advanced AI model, you can leverage that from the US. But to solve that kind of problem, you have to like experiment that yourself with the existing technology from US, from China. And once you can develop that, of course, it takes many years to do it. I don't say it's easy, but at least that thing, once you develop that, you have that kind of unique experience, unique expertise, and no one can replace you. Like because like it's like it's just impossible to copy today. I mean, it takes time. Maybe after many years, maybe after many years, many people can do it, but just not today. And yeah, and the domain expertise like apply to the local problem, that the unique thing. And there's something I would not recommend. So I don't want Vietnam to one day become a cheap labor country. For example, I keep hearing about like some people like want to do like spend effort on data annotation. Of course, to solve some AI problem, you need data, you need annotation. Of course, you have to do it, but it should not be the goal. The goal is to solve some kind of business problem, and then we have AI. Then we need data, we need annotation. We do it because we need it. It's not, but like the annotation itself should not be the goal. Like for example, if you build the whole data annotation for this, someday the GS introduce a new like modeling approach that use less annotation, then your business become like outdated. Then it doesn't help you in long term. I mean, it should be. I mean, should not be the main goal is new business today. So that's why my personal point of view. If someone have different opinion, can share with me.
Thank you, An. Yeah, I think it's very interesting and very insightful. Yeah. Yeah. So it's time to move to section 4 Q&A. If there's a topic you'd like our speaker to explore further, or you're a challenge you're facing in your own organization, or simply a question about physical AI is heading next, we'd love to hear from you. You can either type the question in the chat or raise your hand and ask it directly. Our team's keeping an eye on everything. So I'll bring a few of your questions straight to our speaker. Right. So we have our first question. If Vietnam shouldn't compete on cheap labor or foundation model, what the single most defensible advantage Vietnam can build in physical AI over the next 5 to 10 years?
So okay, there are two things: cheap labor and foundation model. So cheap labor, I would definitely not recommend. Foundation model, there is yes and no for me, because yes, I mean no in like, okay, they don't try to do the same thing that Silicon Valley and China is like doing, like don't try to compete with OpenAI or Anthropic. But like if you can make a specialized foundation model for your problem, your own problem, it's unique thing you can do. I mean, that's require a lot of research. You still need a lot of like PhDs people like put a lot of effort on this. And I think that's still a challenging problem if you have the right problem to solve. Yeah, still foundation model, but what kind of foundation model? For the talking about the world model, think about for the what is the world to you? The world, it doesn't need to be the whole planet or universe. So for the in agriculture, our world can be just a greenhouse or like a field. In the mining, a world is just a field. I mean, a mine. In construction, the world is just like a construction zone. If you can think about, if you think that way, you can make your own world model to your own world. The world is the scope, the space of the problem you want to solve. That's the thing I think like you can do. And yeah, like I mean, more company are not physical. Yeah, I see the yeah. So sorry, can you is this the on everything about the question? Is there, or what is the later part of the question?
So Maya asked, what the most defensible advantage
What
Vietnam can build? So yeah,
Oh,
as
yeah.
you arguing for the world model.
Yeah. So that one example, not everything. Again, come back. The most defensible find the
Advantage.
right problem to solve. I mean, you don't like what is the problem you want to solve? For example, like there is a lot for the Vietnam has been doing a lot of things in agriculture, manufacturing, logistics. And how are people doing today? How can we do better with AI? That's the thing you can chase, and that's a unique thing. When I say that, I mean this problem is does it look similar to the problem in the US in other countries? Right? The frame problem is sounds similar, but like the way you solve it is different. Different countries have different way, and it's incorporate of different like how to roll the rice in Vietnam is much different from how to grow rice in the US. That difference alone, you can build. That's the thing you can build your expertise and make the whole system for this, and you don't have to depend on on other country. For example, you don't have to wait for the companies like our company in the US to finish the whole robotic system for greenhouse. It takes many years. You don't have to wait many years later to do that. You can do it right now with the existing models and hardware in the world. That's the thing you can do from Vietnam independently. You don't have to depend from on the US or China.
Thank you so much. All right. So we also have another question for Mr. Paul. As more companies adopt physical AI, I see there's a lot to handle at once: robotic software, testing, data pipelines, and more. So where do you see Hua in the biggest opportunity for IT outsourcing company to help these firms scale faster without compromising quality?
Yep. Thank you for the question. It's actually an interesting question. So this is all from my own personal experience. I would say with the whole development of LLMs, software in general have become become less impactful when it comes to the whole solution as the whole thing, right? So I would say it's the data pipeline. That is something that would help small companies or IT outsourcing companies to be able to scale faster. So it all ties back to the previous point of being able to understand the problem correctly and collect the relevant data to solve that problem. And so if you can find a way to quickly iterate that whole rinse and repeat process, right? Like you have a way to build, to say for robots, you have a way to quickly build a small robot, go out, collect a whole bunch of data, go back, and within the next 5 days, you improve the robot, go out again, collect more data, go back. There's a way to do that quickly enough through by optimizing the data pipeline or the design process of the robot. Then I think a company would scale better. Yeah. So I think it's the data. It's the data pipeline in general. It's the key here.
Thank you, Paul, for your answer. So we're still waiting for some more questions coming in. Does anyone have more questions? Oh, yeah. So I think this is a good closing point. I think nobody has more questions. Oh, there's a new one just coming in. Right. I have another question for you, Mr. On. So thank you for the question. Firstly, right. So physical AI is often described as the next platform shift after generative AI. However, this ecosystem today is still fragmented across robotic, simulation, edge AI, industrial software, and embodied AI system. From your perspective, where do you think the first large-scale commercial opportunity will emerge? Will it come from robot foundation model, vertical array application simulation infrastructure, or fully integrated embodied AI platform? What are signals should business and talent leader should be watching today? That's a long question.
Okay, that's very interesting question.
Yeah.
Actually, if you ask the question in the US, in Silicon Valley, all this kind of thing are happening in parallel. Like we have everything. We have like robot foundation model. We have vertical robotic application. Like our company is focused in like vertical application, and some company care about in similar infrastructure. And yeah, a lot of company in doing like embody AI, and it depends on like it's like for me, it's kind of like all very opportunity. Like I personally, I asked myself a years ago, what kind of robotic company problem I want to solve today. I mean, I just joined the company last year, and okay, should I join humanoid robot company, or should I join a foundation model problem? Because like although I something, but for me, the vertical application is the quickest path. Means for me, it's the fastest path to see the outcome. You know, in physical AI, to solve problem, you have to wait for many weeks, many months to see the result. And okay, if we work in the foundation model, it can take many years. It's not something you can see the result today, but like, okay, in application, it still happen faster. And to find a solution, you have to act it for the, you have to do to find a solution. And if someone asks me, hey, are you interested in building simulation system? I say, not yet, not today. I know some companies have the right option to do the simulation, but not happen in our case. For example, because the solution is not there. How can you do the simulation without a right solution? You will do the simulation based on the data, collect synthetic data from internet, but like it's not the right answer to your problem. And then for in my case, I would like postpone the simulation to maybe 2 or 3 years later. And many of companies in the US choose this path, because like we choose the problem first, and then we build the system to solve that. First, we have to do it manually first. Then we make an autonomous system to solve that. We create the data, we create the solution. Then over time, when the solution become a button, now we can do the simulation. So if you ask me, okay, I want to do application today, then maybe after this year, when we can have like some form of, okay, what are the right way of doing something, we can combine like agentic AI and physical AI, like have some very like full autonomous system. Then we can worry about, okay, let's make a simulation system like that. Then we can so we can have a lab to experience something new, to expand our business. But like before that, we don't have anything to simulate. I mean, if we do the simulation now, we just own the data, just synthetic data. Synthetic means it's not real data. To have real data, we have to make it happen first. So it's my choice. Like if you ask me, okay, what is the thing I want to focus today? I would do the application first in 2026. And if you ask me, maybe 2027 or 28 or 28, okay, maybe it's right time for simulation. Of course, like if you happen to join a frontier company, okay, you may spend many years to build a foundation. Although I used to talk some like a company working with or if you work for a company for doing the sensing thing, the skin for the robot, it takes many years. You don't have any robots with skin today, right? Because they are still working on this, and this take me another 5 years or 10 years, I don't know. And if you choose that way, you have to wait and spend a lot of effort on it. And okay, and after that you will have that.
Yeah.
Does it answer your
All
question?
right.
Yeah, I know it's fragmented because like the problem is like it depends on what's matter to you, right? What's matter to your business. Do you want to solve the foundation model problem, or you want to? Because one thing is useful in the US, but it's not helpful in many other countries. Like in here in Silicon Valley, if you make a new foundation model, you have customer. Like for example, for the companies working on the application, if we want a specialized foundation model, one day for example, in agriculture, if someone have for the if there are many agriculture companies working on this, so if you can provide a new foundation model, it's helpful to adopt it. But because you just have this kind of, and even myself, I'm an engineer, and I would say that half of my LinkedIn message is not about new job, but like someone is trying to introduce new data product for me. For example, I'm working in data infrastructure, and just in Silicon Valley, some companies just hey Ann, I know you're working in infrastructure, you're working with data. We have a new data product for you. We have a new data tool. We have like a new platform. We have a new framework, like a new open source something. That's not something I mean in. It's something I don't see in other market, but like in the US, like people like work in different level, in different layer, and doing different thing, and in each layer we have a market to do that. We can sell that, but like so from your task, but like where is your market and what is the most valuable in your market? Yeah, it's not the same in the Silicon Valley.
Yeah. Thank you so much, Anand. I think that hopefully answered the question. So yeah, and we're coming to an end. I don't see any more question. So last chance, if anyone have a question, but let's have a quick recap of today's discussion. Yeah, we start with the global physical AI landscape, and then hearing about perspective from expert of Silicon Valley and Australia on the market trends, innovation, and ecosystem development. We then focus on physical AI already being applied across a wide range of industry through real-world use case. After that, we look at the next wave of adoption, discussing both the challenge and also how can organization should be preparing for. Finally, we wrap up with a great Q&A session. Right? Yeah, no more question. Where our speakers share additional insight and perspective about the future of physical AI. So, a robot navigating underground pipe in Australia, unlike a greenhouse autonomous system producing food in California. Neither of these teams set out to build the future of the industry. They set out to solve a specific problem with the tools available today. That's what physical AI look like in practice, not a grand transformation, but a series of decisions made early that compound over time. The enterprise will lead this era aren't waiting for technology to mature. They're the ones already asking what problem should I solve first. Right. So on behalf of our team, thank you all for joining us today. Huge thank again for On and for your insight and also story and the generosity you bring in sharing both the strategy and the live experience. Yeah. After everything we discussed today, what's one thought of message you would like to leave with the audience and we close out this session? Yeah. Maybe On you first. One last message.
Oh, one last message. So to really understand physical AI, thing is it's a movie. So don't just watch the movie, but like be an actor in that movie. Like jump into it, do it. You will see. I will see.
Yeah. Thank you. How about Hua? One last message.
Yeah, I would say it's about maybe having the curiosity and the willingness to go out there and try different things and embrace failure and just keep trying, and then you'll figure it out eventually. Yeah.
Yeah. Thank you so much. I think we all get the message. We have to go out there and do the real thing. Beautiful
Yes.
closing message. Thank you so much. Yeah. So before we end the meeting here, a quick note for everyone: you received a follow-up email with a full recording, today's live, and an insightful gift set from LTS Group and the GDS team as our way of saying thank you for spending time with us. And for those who are joining us live on LinkedIn or Facebook, feel free to leave your email address in the chat so we can send the digital gift set to you. Don't forget to check your inbox in the incoming days. And remember, this is just the beginning. The next episode of our series is Build in Vietnam is coming up next time, and we'll be diving into another key topic, shaping the country tech future. So stay tuned, and until then, take care and see you soon. Bye bye.
Bye, everyone.
Yeah. Have all you all have a nice day.